The novel coronavirus or the COVID-19 has already become a global pandemic, affecting hundreds of thousands of lives worldwide. Amidst all this, I didn't want to lose an opportunity to have a math discussion. I have a couple of questions for you. Let's say someone tested positive for the COVID-19. What are the chances that this person has the disease? If you jump to conclusion saying that the chances are close to 100%, that may not be necessarily right. The second question is, if someone tested negative for the COVID-19 disease, are we sure they do not have the disease? Again, if the answer is that you're extremely sure, that may not necessarily be right. And the third question that I have is, should we do a mass test for everyone in the country or in the world, for example, for the COVID-19 disease? So let's start with the first question. We are told that someone tested positive for the COVID-19 disease, and we are trying to figure out what are the chances that this person really has the disease. So by some estimates, the population affected by this disease is about 1.5%. So please note, this is the mortality or the fatality rate. And these are extraordinary numbers. And just to give you some perspectives, 1.5% of the US population is about 4.5 million. And 1.5% of the world population is 105 million. I sure hope these numbers are not accurate. And this is by far too many people that would be affected by the disease. Now let's talk a little bit about the COVID-19 test success rate, which is about 95%. What this really means is, if we took a batch of 100 people and administered the COVID-19 test, and there are different kinds of tests and each one of them have different success rates, the test by and large would come out accurate only for the 95% of the people. So that means only for the 95% of the people who really have the disease, the test would say that they are positive. And for the rest 5%, it would say that it's positive even though they don't have the disease. So this is called the false positive rate. So here you see two different circles, one in the orange, which represents the 1.5% of the total population who could be affected by the COVID-19 disease. So what that really means is there is the rest 98.5% of the population that would be healthy or do not have the COVID-19 disease. So when we say that somebody tested positive, what it really means is it's a combination of people who were tested positive that had the COVID-19 disease, and also the people who tested positive that do not have the COVID-19 disease. So essentially, a positive test really means there are true positives and false positives. And going back to our main question that we started off with the premise that we know somebody got tested positive for the COVID-19 disease. And we were wondering, what are the chances that this person really has the disease? So essentially what we are trying to do, without using too much of mathy jargon here, is we want to know how many people truly tested positive when you normalize it over the total number of positives that you get, which is really the true positives and the false positives. So what we really want to know is the rate of true positives divided by the rate of the true positives plus the false positives. Say it another way, this is exactly what Bayes' theorem talks about. It says the probability of a hypothesis given an evidence, and the evidence being that somebody tested positive, and the hypothesis is what is the probability that somebody truly has the disease, is given by probability of the evidence given the hypothesis times the probability of the hypothesis over the probability of the evidence itself. So jumping into some rough calculations here, the rate of the true positive is 95% of the 1.5% of the population who would be affected would turn out to be true positives. So that is 1.5% times 0.95, and the rate of the false positives is 98.5% of, or the 0.05% of the rest of the 98.5% of the population. So if you do the math, it turns out that the chances that somebody really has the COVID-19 disease, just given the fact that they tested positive, is really 22% and not close to 100% that we originally assumed it was. So we all exhibit such confirmation biases, and when the underlying data is looked at through the lens of mathematics, the reality that we see is completely different. So here's just an illustration of how you could apply math to sort of effectively understand what the data is really telling you about. Similarly, we can talk about the second question, which was really, if someone tested negative for COVID-19, what are the chances that they do have COVID-19? It turns out that the answer is not really 0%. That means if somebody tested negative for the COVID-19 disease, it doesn't necessarily mean that they do not have the disease. In all that I'm saying, there is a lot of variance here. The results and the rates of success really depend on the types of the tests that is being administered, whether it's a PCR test or whether it's a swab test or a serological test. So there are wide ranges of tests that are present out there, and it also depends on the population it is being tested on. So the point being, it's not close to 0% as we assumed, but it turns out to be close to 8%, which can be a pretty significant number when you apply it to the masses. And the last question that I really had was, do we think that having a mass test of the COVID-19 for the entire population is a panacea? Would it really solve all problems? What if we could all go to a hospital or a clinic or someplace, or even do it at home, and test ourselves for the COVID-19? Would things be better? The answer, unfortunately, is no. When you test this across the population, the chances of you having false positives are really high, and the scary part is not so much about the false positives, but the false negatives, I guess, is also going to go up. So somebody who turns out negative would have this calmness in their mind, saying that they are out of this disease and in fact could be a carrier of this virus. So the bottom line is, tests should be administered only to selective people who exhibit very strong symptoms and who have also had a travel history maybe, or who have come in contact with other people who really have this virus. So I thought I should share this with all of you, and thank you again for watching.